Hi, I'm Brian Mallow, and I'm speaking with Rajiv Prabhakar from Lawrence Berkeley Lab. Hey, Rajiv, how are you?
Hi, Brian. Thank you for having me.
Yeah, well, congratulations. You're one of the 12 finalists for Berkeley Lab's Research SLAM. It's the fourth annual Research SLAM. Have you ever done it before or done anything like it even?
I have not done SLAM before, but I did do something kind of like the 3-minute thesis in my past.
Yeah. The 3-minute thesis. Yes.
Yes.
So this is similar. You're going to have 3 minutes. You get one, not a slide, but a background, a virtual background. Are you going to be using a walk-up song?
Yes, I'm going to be using a walk-up song. Which
Did you choose? What is it?
Maybe you know this song is like war. What is it good for? Absolutely nothing. And then I'm going to I'm going to say something related to my research following that song.
Because your talk is called CO2. What is it good for? Yes. I already thought of that song when I saw the title, so that's great. Perfect. Okay. And where are you from? You're from India. I know you're from India.
Yes, I'm from India.
Let me ask you about your path to Berkeley. Did you always know that you wanted to be a scientist?
Actually, no. In my younger days, like my school days, I wanted to become a police officer. And then, but then I was also like kind of interested in science also at the same time. And then
those are very different. I'm pretty sure I've asked a lot of scientists that question, and that's the first time someone said a police officer.
Yes, it was maybe because I just wanted to be like, help people or like,
not even forensic science, not even the science part, just police officer. Yeah.
Yes, just a cop. Like, I like to investigate stuff. That was more so that investigation mentality. Okay,
yeah, is there any way being a police officer is like being a scientist? What, investigation?
Yeah, investigation, looking for clues, always thinking outside of the box.
That's great. Because I often say that to non-scientists that science is like detective work. And you come on a scene, like here we were plopped down on this planet knowing nothing, and we've pieced together a story like Sherlock Holmes, like detective work.
Yeah.
So tell me, so then from police, this dream of being a cop, how did that morph into science and the kind of science you're doing now? Tell me about your path from India to Berkeley.
Oh, yeah. So after my high school in India, I moved to Singapore to do my bachelor degree in physics. So I wanted to be a physicist. I was motivated, of course, by people like Einstein, Tesla, to do physics. And then I started to move on to a bit more materials, like synthesizing materials. So then I did my master's in material science. And then that's when my passion, during my master's, when I got the passion about energy research for climate change, renewable energy. So then I try to focus more on that. So I did that in my PhD in Switzerland. So after my PhD in Switzerland, I came over to Berkeley for my postdoc.
Wow, so you've been all over. That's what I love that about the academic life. It's usually like that. You have to go where the jobs are and you end up globetrotting, and that's great.
Yes.
So, and you're currently a postdoc in the Energy Sciences Directorate, Energy Science, Chemical Sciences. Isn't it all just physics? Is that I don't know if chemists get offended or biologists get offended by that, but physicists say it's all physics in the end, right?
So what is it? Says it's all mathematics.
I really love, I really love what you're talking about. Is it, you didn't use this phrase, but is this like synthetic photosynthesis? It's like, is that an appropriate phrase to use for this thing that you're studying?
Yeah, that is very accurate. So we want to make an artificial leaf, basically. We want to do what plants are doing very easily for many, many years by us.
That's excellent. Yeah, so it's like to take, so that's what is it good for? CO2. Plants find, a leaf finds a use for CO2 and water, and it makes fuel. And that's really interesting. What drives your interest in this? You know what? I actually want to ask you one technical question though. Are we able to match the efficiency of leaves
Okay, that's a good question.
Maybe that's too long for a 5-minute interview, but
yeah, but very quickly, like plants are not as efficient as us because they absorb only a very small part of the sunlight. So with our materials, we can absorb a broader portion of the sunlight. So the only question is whether we can make it cheaper and in a large scale so we can commercialize it. So that's the basic question.
Wow. But even though nature has 4 billion year head start, maybe a 3 billion year head start on you, we've actually, but because we can tweak things like the light source and stuff. I know that in your talk, you talk about like choosing the right frequencies and to get the most efficient. That's fantastic. And I guess leaves can only they make use of the light probably that's most abundant. They do the best what they have with the sun as a light source, but you can use a different light source than the sun.
So we can use a lot more wavelengths of the sun, basically. Leaves use like a very small portion of the sunlight. So that's why we can, and we have the power of making new materials, so we can tweak. We have a lot of freedom with tweaking.
Yeah, fantastic. Do you and what's your goal? Do you have a goal? Is there a problem you're trying to solve? Is there a sticky problem or anything that you're really trying to figure out now?
Yeah, true. That's basically we are trying to understand more on the fundamental level how these processes happen on the materials we have. So how the CO2 can react with my material in water and in sunlight. So I want to answer those fundamental questions, which I'm still not yet. It's kind of understood, but there is still a lot of room where it is like there's nothing. So there's a lot of room for us to investigate.
Yeah. Is there, so a lot of people don't even know a scientist. And as we've seen with so much misinformation today, there's so much that people don't understand about the scientific process. Is there anything that you wish people better understood, that the general public better understood about science and the scientific process?
Yeah, definitely. There's one burning question which I want more people to think about it seriously, like take the question of climate change more seriously. I mean, that I'm not, there's definitely a lot of people who are seriously working on that problem. Even governments are also investing a lot of money and resources in that. But I still feel that not everybody gets the urgency of dealing with it right now. People are like, oh, maybe it won't affect me. It will like maybe take 50, 60 years, but then is the only thing is you gotta work on it right now. So only that it will be fine in the future generations.
Right. And I was going to ask you about your motivation, what gets you up to do this kind of thing. And does that urgency feed into it? Like, are you feeling like, oh, wow, we have some serious stuff and you're in a position to work on it?
Yes, definitely. That's one of the main motivations for me to choose my research area. So it's that the thinking that hopefully my research will contribute, at least in a small way, to the global problem. Yeah.
Excellent. And beyond your research, so you're doing the research SLAM. It's your first time. What are your feelings towards it? Are you nervous? Are you excited?
I was not getting nervous for a while, but as the deadline comes, I am starting to get more and more nervous. Yeah, but I realized that there's quite a few things that I need to practice besides the actual script, like, getting the technical stuff correct with the green screen, with the slides, how I dress. So there are like quite a few things which I've not thought about, but I have to pay attention to that.
Yeah. And did you go into this? What do you think, besides your research, scientists have enough work to do with just the research? Outreach is a whole other aspect and could be a whole other job for some people like me. So what do you think is outreach important? Why are you even doing the research SLAM?
Yeah, definitely. Outreach is very important. And my motivation for the SLAM is that so that I can help people who are not in my field try to understand, like people outside my field, not only outside my field, like even the general public who don't have any science background, to understand what we're doing at Berkeley in our lab. So that's one of my motivations for the SLAM. Yeah.
Excellent. Well, hey, congratulations on being one of the finalists at Berkeley, and good luck. And thanks for taking the time to talk to me.
Sure. Thank you, Brian. Thank you very much.